Hello and welcome to the Introduction to HTML and CSS by 3D Buzz. My name is Nelson and I will be the instructor for this course. So what this course is it's going to be an introduction to HTML and CSS for designers and developers. I want to set expectations for this class right now and say that we are not going to be making very many functional things insofar as scripting, but we will be covering all of the fundamental topics that a person will need to understand in order to be an effective web designer or an effective web developer. Now, I know a lot of designers in the field think that they can get away with not understanding HTML and CSS and the technical side of web design, but I find in my experience, which is I've been a web developer for quite a few years now, that is really a downfall as far as designers go. It's really important to be able to understand HTML and CSS. Almost any job you will want to go to that requires web design is going to require knowledge of HTML and CSS. Now, the same thing goes for developers. I know a lot of web developers who, they're coders, they like writing code. I like writing code, but they don't give HTML and CSS the attention that those technologies deserve. So the way I have this course organized is the first 4 weeks is what you're in right now, and that's going to be an introduction to HTML and CSS. The first week today, we are going to cover a lot of basic terminology. We're going to be talking about what HTML is, what CSS is, what HTTP is, how to get a web server going, and writing out a very basic HTML document and kind of talking about the syntax. I know at the end of this class at the end of this particular session, it might seem a little anticlimactic. However, the next 3 sessions are going to be delving into things like the box model, how things are positioned on a web page, how to get something to look a particular way, new features introduced in CSS3 and HTML5 that make styling a web application a lot easier, or a web page a lot easier. So we will definitely be picking up on some really fun stuff later, but I wanted the first class to take a kind of academic approach into the technologies that we're going to be discussing, because there are a lot of technologies that we need to understand in order to be effective web designers or web developers. So I said that this is the first part of our web development course. So these 4 weeks are HTML and CSS. The next 4 weeks are going to be JavaScript. And so we'll look at JavaScript and how to make our applications responsive on the client side, which is a term I'll be defining later. The 4 weeks after that will be an introduction to HTML or ASP.NET MVC, which will provide our applications with dynamic functionality that takes advantage of things like databases and other sorts of fun stuff. But the reason I decided to do it in this order was because every bit that we go through in these 4 weeks will be a prerequisite for what we go through in the next 4 weeks, and the same is true for the final 4 weeks will be everything that we've covered. This sentence is getting out of control, but you guys know what I'm saying. So let's jump into what we are going to be talking about. What I'm going to do is I'm going to write out a simple HTML page, and I'm going to want people to follow along later. If you guys want to follow along right now, then that's great, but I want to write out a simple HTML page and give people a sort of grounding about what exactly we're going to be talking about. After that, we're going to be talking about the technical side of the technologies we're using. What is HTML? What is HTTP? What is CSS? And so on. We'll be playing around with a little bit of CSS in this class, and then we are going to be talking about web servers, and we're going to wrap up this class with getting a basic web server set up, which will be a prerequisite for anybody who wants to continue following along with this course. So let's go ahead and get started. I'm going to open up just a browser window. Again, this course is going to be operating system independent, so whatever browser or file explorer you guys use. Jump into a random directory on my hard drive, right click, hit new, and I'm going to create example.html. Okay, so we have an example.html and it's an empty HTML document. If I were to double click on this, we get Chrome window, because that's my default browser, and we get nothing inside of it, which is appropriate because there is nothing inside of it. Then what I'm going to do is I'm going to right click and hit open with, and I'm going to say choose default program because I forgot to do this before class. And I'm going to locate my awesome Sublime text editor. Okay, let me, there we go. And then I'm just going to click and drag and drop stuff and things. That's what I get for firing up a VM and not configuring it before class. So now we have a text editor. All we're going to be doing is writing text. That's what HTML is, that's what CSS is, that's what JavaScript is, that's what C# is. It's just a bunch of text. And I'm going to be throwing a bunch of text at the screen right now. I want people, and I'll be showing you guys what starts to happen as I add that text. But I'm not going to be defining any terms quite yet. I just want to show people the example page that we're going to be writing for this particular class. So we start off with our awesome Doctype. Then we open up HTML, open up head. Let's toss in a meta tag up here with a char set of UTF-8, which will be defined in length in this class. Then toss in a title. And here we have basically the minimum valid HTML document that you will ever see. If I were to refresh this page, the only interesting thing that happens is now we have a title of our document that says to do application. Jumping back into my text editor, let's fill out the body a little bit. So I'm going to start off with a header. I'm going to give my header an H1 tag and say my to-do application. Actually, no. To-do application. We'll talk about that as well. And then toss in a paragraph and say, this is a sample application. So basic stuff so far. Again, I just want to get people sort of acquainted with the syntax before we define it. Next up, I will open up a section. This section will be interesting because it will contain a form, which we will open up right here. Then we'll toss in a few divs with some attributes that will definitely be defined. So we have a div with a label and an input. So far we have some HTML defined in our page, and if we jump back over into this, hit refresh, we have a form now. But don't get discouraged too yet. I want people to see what HTML is before we talk about what it does. So next up, we'll enter another form row. And also, that's kind of why I didn't want people to follow along right now, because this will look very, very alien to people, incredibly alien to people, which is good because that's what this class is all about. So next up, we will have a form row, and we'll stuff a label in it and give it a for list, and then say list, and then end the label. And then, how about put in a select list ID of list, and then toss in some options, value of today, option, blah, 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 tomorrow, future, tomorrow, future. Finally, we'll end this form out with a submit row, which I will define as a single element. Again, I'm typing in, or I'm saying things that I haven't defined yet on purpose. And then we will put in something right here, finish example, and then dump in a footer. And because I'm so proud of this particular page, I'm going to go ahead and copyright it, because I don't want anyone stealing my work. Okay, so we'll start off with this. We will continue with this example a little bit later once we get some terms defined, but I wanted people to actually get a taste for what HTML looks like, how I'm formatting my code, and what to really expect us to be able to do. Because when I jump over into my browser window and hit refresh, we now have our header, a paragraph, another header, a form, and a footer. So that's really cool. But let's back out. What is HTML? HTML stands for Hypertext Markup Language, and there are two words within that acronym that are very important to understand, and one is hypertext and the other one is markup language. Hypertext is basically just text, plain old text, the kind of text you type into Notepad or an email or whatever, but it's annotated. And what I mean by annotated is we give bits of text special meaning by wrapping them in something called elements. We wrap them in tags and turn them into elements. So the whole goal of HTML is to express hypertext. And the goal of hypertext is to express text, but with additional things associated with that text. Like you'll notice right here, I have text, I have to-do application, but I've annotated it. Or another word for annotate is I've marked it up. I've marked it up with hypertext, which again brings us back to what HTML is. Hypertext markup language. So hypertext markup language was created by Tim Berners-Lee in 1991, I believe is when he published his first draft. And the goal of hypertext was initially to create interactive papers for CERN. CERN, which is that big organization that does a bunch of physics and stuff. I'm not a physicist, but I'm sure you guys all remember them for their recent experiment called the Large Hadron Collider. So Tim Berners-Lee decided that he wanted to write these academic papers and be able to express them in ways that weren't previously possible. He wanted to express them with hypermedia or hypertext, where he could annotate specific aspects of that text and make them sort of a rich document. Most importantly, he wanted to have links in between different documents so that you could define one document and then have another document that has some sort of link in between them. So he wanted to create this hypertext, and he did so in 1991. And he created the first web browser and the first web server. And the idea is that anybody on any computer who has a web browser that understands HTML can communicate with these web servers, and we could get the same result no matter where we are in the world. But as we all know, that stuff kind of really took off in the 90s. People realized that hypertext is such a powerful means of communication and expressing documents that, well, it became a sort of ubiquitous language on the internet. And you could argue that the World Wide Web is in large part responsible for the internet becoming what it is today. But there are a lot of things that happened in between 1991 and today. And people started to realize that they wanted to use the web for things a little bit more complicated than basic academic papers. So what they did is they expanded upon HTML and all of the related technologies under HTML to give us the kinds of experiences we can now have on the World Wide Web. I mean, take a look at BuzzNet. A lot of you people are in BuzzNet right now. BuzzNet is expressed entirely in HTML and CSS. That application that you're using right now is a combination of JavaScript, HTML, CSS, and a web server, and that's all it is. So people today want to create their own web applications and their own websites, or want to design web applications and websites. So we need to go back to the basics and talk about what is the fundamental building block of any web application, and that is HTML. HTML is a language that is understood by a web browser being something like Chrome. So HTML has a very interesting history. I don't want to spend a whole lot of time talking about it, but everybody knows nowadays, everybody's heard the word HTML5 and CSS3, and those are recent additions to HTML that have been put together by the W3C, or the World Wide Web Consortium. I don't know if I pronounced that word right, but I hopefully got it close enough to where you'll understand it. What those are, what HTML5 is and CSS3 are, is they're just extensions to what Tim Berners-Lee originally created with the original versions of HTML. HTML4 was standardized, I believe, in the late 90s and has been pretty much the de facto standard of HTML since then. Nowadays we have HTML5, which isn't actually completely standardized yet. Basically, we had a browser war or two browser wars. The first one was with Netscape and Internet Explorer, which caused a lot of great things to happen, but then everybody settled on Internet Explorer and web standards stagnated. In the last 4 years, 5 years maybe, we've had another browser war where other browser vendors such as Mozilla with Firefox or Google with Chrome decided to start creating a browser experience that was markedly better than what Internet Explorer had available. And then they took little bits and pieces from the working draft of HTML5 and started throwing them in their browsers. And then they've thrown enough of those little bits and pieces in their browsers that web developers are starting to use them, which forced Microsoft to catch up with their own browsers, and then just the whole thing happened, and yeah, it's kind of a mess. But what is good about that is now we have a whole array of new toys to play with, and that's what this class is going to talk about quite a bit. So again, HTML is really basically just a language of describing a document to the browser. It describes a document in the form of a hierarchy which you can see visually represented on the screen right now. For example, you'll notice that I have this little H1 doohickey in this header doohickey. The header doohickey is in the body doohickey, and the body doohickey is in the HTML doohickey. So we have a hierarchy of what are called elements. And an element is basically just a way to delineate our text by some sort of semantic. Now, you'll hear that word a lot with web development, especially modern web development, and that's the concept of semantics. And you could look up the English definition of the word semantic, but I'll go ahead and define it in a way that will make sense in this context. And a semantic or semantics is a way to give text meaning. And once we give text meaning, our browsers can render that text in a particular way. Now, we can override that rendering to whatever degree we want to, but we'll talk about that later. So you'll notice right now that I have to-do application, and I've applied semantics to it by wrapping it in what are called tags. HTML has the concept of a tag, and a tag, you may either have an opening tag or a closing tag, and anything in between those two tags creates an element. So right now we have an H1 element with the text to-do application. You could say that we are marking up the word to-do and the word application with the semantics of an H1 element. But you'll notice it doesn't stop there. We also have other semantic elements that we can take advantage of, such as headers and sections and footers. Now guess what? These are HTML5 elements that were introduced to the language HTML very, very recently. And I will say this markup will not work quite right on Internet Explorer 8, for example, because Internet Explorer 8 did not understand these elements. But we are not talking about Internet Explorer 8. We'll talk about how to get some level of compatibility with older versions of Internet Explorer later. But what I want to focus on is what the majority of modern browsers understand. So the purpose of this document that I've written out here is to express some sort of presentation, or not necessarily presentation, but some sort of meaning to the browser. I've given this text up here the meaning that it is a header. I've given this text down here the meaning it is a section, and I've given this text down here the meaning that it's a footer. And that's all we do with HTML. We give different things meaning by applying different tags to them to create elements that browsers understand. Because if I jump back into my Chrome window, you'll notice that I'm not seeing the result of, or I'm not saying just this being rendered out, the raw HTML being rendered out. I'm seeing the result of the browser interpreting all of this text and applying all the semantics that I've told it to apply. So that's some of the stuff about body. We'll jump back into that in a moment here. But let's back up to the top of this document. Now, we'll be spending most of our time in the body, but it's important to understand why do we have to include this guy right here? Why do we have to specify an HTML element and so on? Well, the first line of any HTML page is going to be the doc type, or the document type. And the doc type tells the browser what version of HTML that you're using. There are a variety of different doc types available. You have the HTML4, HTML4 transitional, HTML4 iframe, you have the XHTML doc type family, and then you have the HTML5 doc type. By putting this up here at the top of my page, I've instructed the browser that everything that follows is going to be understood as HTML5. If I omit my doc type from right here, what we do is our browser enters what is called quirks mode. Quirks mode is something that it exists for historical reasons. Remember how I mentioned there was a big browser war first between Internet Explorer and Netflix, and then after that there was the huge thing with Firefox coming in, and then Google was like, wow, Firefox is really awesome, let's make Chrome, and then they made Chrome, and then Internet Explorer was like, ah, crap, we suck now, so we got to make Internet Explorer 9 and 10 and so on. And quirks mode was back when there wasn't much standardization about how HTML should be appropriately rendered by a browser. We never, ever, ever want to enter quirks mode. Again, to enter quirks mode, we remove our doc type. So what we want to do is we always want to specify doc type at the top of our document. And there is absolutely no reason as of right now, as of the modern web of 2013, to ever include a doc type other than what I have right here, with the exception of XHTML5, which I will talk about momentarily. So here's our doc type. It is important, it is constant, put it at the top of your HTML documents always, otherwise you will get very odd behavior, which you do not want. So next up we have the HTML document. Now, the HTML document, or element, sorry. The HTML element is just what you do. Now, I could sit here and lecture you guys about Signal and XML and all the other kind of sort of related things that have to do with that HTML that were the reasons why we placed this here, but just take it for granted. We place the HTML element as the root node of our document. Now we get into something a little bit more interesting. We have a head and a body. So notice how everything in our document is enclosed in either a head or a body tag. Our head tag is, or our head element, is where we place all of our meta information about our page. What I mean by meta information is information that isn't really important to the meaning of the document, but is required for ancillary purposes. So, I mean, that's close enough. It's not a perfect definition, but I hope it works for you guys. What we have here are two elements inside of our head tag that give our document specific characteristics. I'll talk about this one second. So let's talk about the title first. The title element is, well, it's what makes the title appear. There's not a whole lot more to that. If I put in my application 123, jumped over here and hit F5, we would see my application 123. Not particularly interesting, but important to know. It's also important to know that the title element is required for standard HTML. If you do not have a title element, you are not writing standard HTML. So that's our title element. Again, it's in the form of text that is being marked up by these tags. So text that's marked up by tags equals an element. And that's what we have here. We have an element. So we see the first tag right here, second tag right here. They're related because this tag has absolutely no punctuation other than the name of the tag, whereas this tag has a slash at the end. That slash is important because it tells the browser or whoever is parsing this HTML, that this is the end tag of this element, and anything before this but after the begin tag is what's going to be considered to be the element. So yeah, we have an awesome title. Next up, we have a character set. Now, character sets are vital to understand in order to not get yourself in a situation where you will have odd behavior associated with your text. So because this is kind of a big discussion, I want to leave this sort of to the end. But I can assure you that if you do not understand what a character set is and you do not explicitly define your character set to be something sensible, your application will eventually blow up. But again, that's a little bit of another academic discussion that I don't want to get on a tangent to right now. Arguably the most important element of your HTML structure is your body. Your body is, think of it as this viewport. We're looking in a viewport right now, and we're looking at a viewport into our rendered application. Our browser picked up this HTML, rendered it, and stuck it in this viewport. And everything that's going to be presented inside of this viewport is going to be made available inside of the body element. So, pretty straightforward. Now, next up, we kind of are getting to the point where I just have to say I put it here because I wanted it to be here. And that's exactly what I did. I wanted a header. So what did I do? I opened up a header element by specifying a open tag for the header element. I know that sounds redundant, but I do want to get this terminology solidified in your guys' heads because tags and elements and that sort of stuff is really important to understand. Next up, we have our H1. We've already kind of talked about a H1, but what is an H1? Well, if we ever want to define the sort of title of the current section of the page we are on, we use an H1 tag. An H1 tag is a header 1. There are 6 headers. We have H1, H2, H3, H4, H5, and H6, and we can use them to create a structure to our application. So for example, if I have a H1 up here to do application and then a following P tag, I might want a H2 right here and say about the application and so on, and then this is more stuff. So on and so on and so on. So we can use our H1s through H6s to create a structure for our document. Again, HTML is all about marking up our text and giving it semantics. That is it. We are giving meaning to text. We're not styling the text. We are not presenting it in any other way than the browser will present it at by default. And we are not adding functionality to the text by instructing the computer to do something. We are simply creating a document which contains text, and the text has semantics, and it has semantics because I've wrapped it in tags. So here's the H1, it's the header. You might think, well, putting an H1 inside of header tag seems kind of redundant, and it kind of does, but the way that I justify the semantics of this aspect of the page is that I have something that follows the H1 that isn't a header, but is still something that I would want to be considered to be the header. And that is a small description of what the to-do application is. I wrap that inside of a P tag. So notice how I have the opening P tag right here and the closing P tag right here. A paragraph, or a P tag, just defines a paragraph of text that you want to display. It's that simple. If you have a paragraph of text that you want to display, you use a P tag. Again, I know I'm getting to the point where I'm saying, or you might be wondering, well, why do you use this here? And again, the answer is because I wanted to. I had a paragraph that I wanted to present to the user. And because I had a paragraph I wanted to present to the user, I wrapped it in the closest element at my disposal that matched the semantics of what I wanted to express. I wanted to express a paragraph, and the most semantically correct element to express a paragraph with is a paragraph tag, which is just P. So that's our header element. Everything inside of this header is considered to be the header of the application. you put a lot of fun stuff in headers like logos and navigation menus and stuff like that. I'm sure everybody is familiar with an application such as Facebook where you might have your top tabs where you have your little notification bar and search bar and all that stuff. That would be the header of the application. Next up, I defined a section. Now, a section in HTML is basically just a way to delineate a logical grouping of elements. So let me go ahead and define the word delineate, because that's not a word you hear often outside of programming, even though it is an English word. Delineate just means to separate. So I wanted to separate my form semantically from the rest of my elements, and I did that by using a section. And sections, an example of a section is right here. I have a form with the header, and I want this to be considered its own block inside of my document. So I used a section. Again, I didn't use a section because there is in the HTML specification, quote, if you write a to-do application and you have a form inside of it that allows you to add a task, you must wrap it in a section. That's not going to be in the HTML documentation. But what is going to be in the HTML documentation is the definition of this element. And it happened to be that this definition of this element matched closely what I wanted to express to the computer. I wanted a add an item form, so I dumped it in a section. That's a very common theme. Remember, when we're working with HTML, we're programmers. We tell the computer what to do. HTML is just a bunch of tools that we can use to express our intentions to the computer the best way possible. So what I have right here is another H1. Now, some people might say, well, you have multiple H1s on your document, that's bad. Well, after large amounts of consideration by the W3C, H1s are now considered to be associated with the section that they are under. So an H1 inside of a section is perfectly valid. I could have another section with another H1 inside of it if I wanted to, just like how I have a header with an H1 right here. I know that this H1 is the header for the page because it's in a header element. I know that this H1 is the header for this section because it's in the section element. Because they're nested in this way, I can follow the semantics, and so can the browser. You'll notice something interesting about how the browser renders this, though. Again, the browser has a default rendering for every single element you're going to throw at it, although we'll be overriding that to make the site actually look half decent, next week. But you'll notice that the default styling of our page actually starts to look kind of like a hierarchy, because this to-do application is a bit bigger than this add an item. The reason it is because this H1 is owned by a section, whereas this H1 is owned by a header. The semantics of these elements dictate that this is considered to be a sub option. So, next up, we have a form. So a form in HTML is a way to present different fields. I'm sure every single person in here who has used the web for any purpose has used a form. And a form allows you to group together a bunch of related fields, such as text fields and select boxes and all that fun stuff, and package them into a single unit that might be sent to a web server. So I wanted a form here. Again, I wanted an add an item form. So because I wanted a form, what's the closest markup that I could use for that? A form. So that's why I used a form here. Next up, we have some divs. So I'm going to go ahead and collapse these divs here. I can't collapse that one for whatever reason. But we have some divs. A div with this little guy right here, this class. So again, I'm going over this just to talk about what HTML is and what the different little bits of syntax are called. And we have right here, a div element with an attribute of class, and that attribute has a value of form row. This is the syntax for providing attributes to HTML. Now, this isn't the only way we can provide an attribute to an element. These quotation marks are not actually required. I could quite easily have done that and the browser wouldn't care. That being said, for readability and for based off my own experience during the whole like XHTML craze, which has died out, I really do prefer putting the quotation marks in there. Now what happens is, by providing an attribute to an element, we are giving that element additional characteristics. So an element may have some default characteristics to it depending on what kind of element it is. Like an H1 is a header, a P is a paragraph, blah, blah, blah. But we can override those characteristics by providing attributes. And an attribute is in the form of a name, followed by an equal sign, optionally followed by quotes, but you will always see me use quotes for these, followed by a value. So you might be looking at this and saying, well, what does this mean? What semantic value does this add to my program, my site at all? I threw in the div element in here for a specific reason, and that is because the div element does not actually provide any semantic value to our document whatsoever. A div element actually stands for divider, and we use div elements when there is no semantic markup that we can have at our disposal to express what we want to. See, what I wanted to do is I wanted to have my task label followed by my input label, but then I wanted it to be grouped outside of my other form element. Because I wanted it to be grouped outside, I had to wrap it in an element. Then I had to decide, okay, well, what element should I use? Unfortunately, there are no semantic elements that allow me to express what I want to here, so I use a div. Because divs have absolutely no semantic characteristics whatsoever, I annotate this div with a class, and then I give it my own custom semantics. The computer doesn't know what a form-row is. That doesn't do anything for the browser at all. I could easily have omitted this if I wanted to. But we'll see very shortly once we get into CSS that annotating our elements with classes gives us a lot of flexibility in how we want those classes to be styled. So again, I know I haven't defined what a class is. What I wanted people to take away from this discussion about divs is two things. A, divs provide a way for us to divide content where there is no appropriate semantic markup that we can use. And two, we can use attributes in order to add additional semantics to our elements and extend them in ways that the computer doesn't know how to do natively. Okay, so after we have this divider, we have two little things in here. We have a label and an input. Now a label, well, let's just start off with what I wanted. Again, I've been sort of organizing every single justification of these elements by talking about what do I want. What I want right here is I want a label to give my following input some sort of description so the user knows what to do with it. Because that's what I wanted, because I wanted to express something to the user about the following input, I used a label because a label is the closest, most semantic element that handles this purpose. The purpose being, I am annotating an input. You'll notice that we have an attribute right here. So that's very interesting. We have an attribute, and that attribute is called for. For attribute only exists on labels. And what it allows us to do is it allows us to tell the browser which input we're talking about. We need to tell the browser which input our label is talking about in order for the browser to be able to do something like this. Watch when I jump over to my application and I click on the word task. You see when I click on the word task, it highlights my input right there? That's because I had added the for there. And again, the for just allows us to instruct the computer what label or input we're talking about. So next up we have an input. Now this is an interesting element for a variety of reasons. There's a lot to talk about on this line. You'll notice first of all I have a type equals text. Now there's a variety of different input types in HTML. We have text, we have checkboxes and radio buttons, we have emails and dates and all sorts of fun stuff. But right now I just wanted text, so I typed in type equals text. Again, this is an attribute that is modifying the behavior of the input. And in this case, it's modifying the behavior to present the type of input that I want the user to see. I want them to see a line of text, therefore I use the type equals text attribute. Now you'll notice these two guys. The name is very important because it tells the browser what name this data has in the context of this form. However, we're not going to be really talking a whole lot about form submission, so I don't want to get into it too much. But I want people to understand that a name, all a name is it's a way to tell the form what our element or what our input is. In this case, it's task. The next one is ID. The only reason I put the ID element inside of, or attribute inside of this element, is because this ID relates to this for. The for a label has to match up to an ID of an input. So I put the ID in here because I wanted this for to match up to this input. Not a whole lot more to say about that. We'll be talking a lot about IDs later. So I don't want to define exactly what an ID is quite yet, but I did put it in here for a purpose. Next up, we have this guy. So look at that. That's kind of weird, right? Remember how I defined an attribute as a name followed by an equals followed by text? Well, that's not always true. Attributes in HTML can simply be a name followed by no equals and no value. Now that's not true for XHTML or XML, but it's true for HTML. And what we can do here is we can use something like the required attribute. The required attribute is a new addition to HTML as of HTML5 that instructs the browser that when I click or try to submit the form, the browser is going to tell me, please fill out this field, and it's not going to let me submit the form. So that's lots of fun stuff. The next up, we have the placeholder. A placeholder is a different or a new attribute inside of HTML5 that allows us to give this little grayed out text right there if we haven't entered any text. So again, it's sort of like a user experience sort of thing where we're just telling the browser when they don't have any text in here, put that in the background for them. So we have an input. The reason I put this input here was because I wanted an input with the type of text, the name of task that is required and has this placeholder. Because I wanted those things, I typed it out. I mean, again, there's no thing in the HTML specification telling me that this is a requirement for to-do applications. This is me expressing to the computer what I want it to do for me. So finally, we wrap up this div. So that is that div, that's that divider. I wanted to group my label and my input together, but there wasn't really any way to do that with semantic HTML. Next up, we enter another group. This is another div, and I've given a form row class, just like I did up here. That does nothing to the browser, but it will be something that I can take advantage of as a programmer later. We open up another label, and this time we give it the label of list for list. Then we open up a select. Now selects are lots of fun. Those are basically just drop-downs. So when we have a select, we get a drop-down. Select elements may only contain option elements, and those option elements may have a value attribute and text inside of them. So that's something that is part of the specification of HTML, because some elements can't be inside other elements, and some elements can only have some elements inside of them. And with a select element, you may only have option elements inside of them. Well, I don't want to get too complicated, but let's just say one of the elements you couldn't put a div in here, for example, is what I'm trying to say. We could get onto a huge amount of tangents with option groups and all that fun stuff, but that isn't really required right now. What's important to know in this case is that these option elements could not exist outside of a select element. I guess that's a better way of putting what I was trying to express. So because this select element owns these option elements, it uses these option elements to modify how the select list appears in the browser. So as you'll notice, if I click on this dropdown, I get these three options. I get these three options because I told the computer I wanted these three options. If I had no options inside of the select list, and I jump back into the browser, now it's a really empty, not very useful list that doesn't really do anything. So yeah. Alrighty, so here's our select. We'll get into form elements a lot later, mainly in the JavaScript class, but I wanted to show you guys these because they provide a great example of some of the language of HTML and the terminology that you need to understand. Next up, we have another divider, but this divider I'm calling submit row, and we'll see why that's important very soon. However, I did want to show an example of using a div with a class because that's something you will see a lot. Inside of our div, we have an input of type submit with a value of add task. What does this do? Well, we can look at what it does. It creates a button with the text inside of it, add task. Most importantly, when I click on this button, well, it's not going to let me, but when I click on this button, our form becomes submitted. So I don't really want to talk about what form submissions actually do quite yet, but I do want to point out that the submit button is what's going to tell its parent form when it needs to be considered to be submitted. So here's our form. It's pretty, straightforward. I know a lot of this stuff looks alien to people who have never seen HTML before, but if you all you got to do is ask yourself, what is this text being marked up by? Well, this text is being marked up by an H1 tag. That means it's a header. What is this text being marked up by? Well, it's being marked up by a label, but it's a little bit more complicated than that. It's being marked up by a label for the task field. So when reading HTML, you really have to sort of see the structure in your mind, which is why I've indented things the way I have. The browser actually does not care anything about indentation. This would be perfectly valid HTML that would be rendered by the browser just fine, as you can see. However, that makes it very difficult for the programmer or for the designer to be able to quickly navigate the code. Because by providing proper indentation, we can immediately see which element owns which other element. So we know that the H1 is owned by the section. We know that the input is owned by the div, and the div is owned by the form, and so on. We have a hierarchy. So that's our form. And down here, we have an example of a comment. A comment is something that is ignored by the browser. It's something that we can put in for our own purposes. It's ignored by the browser, it's not displayed, it's not rendered, it doesn't affect anything. So that's a comment. Almost every programming language that I know of supports having comments, and that's what they look like in HTML. Not a whole lot to say about it. Finally, we end our body tag with a footer. Why did I use a footer? Well, I used a footer because I wanted to display my copyright notice, and the closest semantic element to display a copyright notice at the bottom of the page is a footer, because that's actually what it's called. It's called a footer, so I used a footer. So yeah, so that's about it as far as this page. What I'm going to do really quickly here is I'm going to finish out the example and actually show some data being presented by our application. Remember, HTML is all about presenting structured data to the browser. It's not about styling. It's not about making something look a certain way. It's not about creating headers and, it's not about creating visual headers, I should say, and visual navigation bars and drop-down menus and interactivity and all that fun stuff. That's not what HTML is about. HTML is about presenting data. So let's present some data. Right now we don't have a whole lot of data we're presenting. We just have this nice little form right here. But let's bring in something a little bit more interesting. The data I want to represent is the view of my to-do application. So I'll start off with another section. Inside of this section, I will give it a header of to do today. Inside of this, I'm going to open up something called an OL. Talk about what that means in a moment. With an li, with a del. Let's throw in another del for fun. Seriously, the first time I wrote a HTML, it was actually lots of fun for me because as you'll see, we're just expressing this text to the computer. We go back to our browser, we refresh, and it's there. It's actually lots of fun. That's why I very much encourage people. In fact, it'll be a requirement to type out this example for homework, because I think that'll solidify a lot of people's feelings about HTML. So here's our to-do today. We have an H1, an OL, an LI, and some DELs. I'll talk about that in a moment here after I finish my next two sections. And we look at how this gets presented to us in the browser. So we have our to-do tomorrow. Now let's toss in one more section. You'll notice that these sections relate to the options I have right down here. There's no actual correlation between this text and this text. It's just that's how I wanted the page to display. So now we have our to-do in the future. Let me go ahead and get my capitalization to be a little bit more consistent here. We'll open up an OL and let's put in an LI. So here's the data. Again, HTML is all about presenting data, and I've now presented data. Now I know that people who don't know what OLs are aren't going to know exactly what kind of data I'm presenting, but if I jump back over to my browser and hit refresh, we'll see something interesting happen. Now we have three more headers, so we have three more sections in our page. The first one is to do today, to do tomorrow, and to do in the future. And each one of these has a list. Now the kind of list that we're looking at is called an ordered list, which OL stands for ordered list. So what I wanted to do is I wanted to display a list to the user, so I decided to use a list. There are three kinds of lists that you can use in HTML. We can use ordered lists, unordered lists, and definition lists. Right now we're just going to talk about ordered lists. Wow, if I say that word too many more times, I'm going to be incapable of pronouncing it for the rest of my life. Okay, so we have our OL, and our OL opens up a list. And inside of that list, we have LIs. LI stands for list item. When you have a list element, or specifically when you have an OL or a UL, the only thing that can go inside of those elements are LI elements. Those LI elements are used to delineate each individual item inside of the list. So you'll notice the way my browser renders them. You notice the 1, 2, and 3, and the 1, 2, and 3, and the 1. Notice also how they're indented further within the page. That's because our browsers kind of have a default way that they present an HTML document to the user. And when we open up an OL, the browser is going to list it for us, just like how we might do inside of Word or Google Docs. So now we have a list with 3 items in it. Notice how I have the del tag right here, or the 2 del tags, 2 del elements. Del stands for delete or deleted. And the semantic way inside of HTML to tell the browser that something has been, or an item is deleted, is to wrap inside of a delete element. So what I wanted to do, again, this is like the 10th time I've done this, but I'm going to do it again because it's so important to understand. I wanted an item in a list that was presented to the user as if it had been deleted. So what do? Well, I create a list by opening up an OL. I open up an LI for my list items, and then I open up a del tag for my deleted item, and then I put text inside of here. I'm adding semantics to this text, because without all of these semantics, without the fact that it was deleted or that it's a list item or that it's in a list, it would just appear as normal text. So that's lots of fun. We got a basic list, and we can throw in the del element to mark it as deleted. You'll notice that in HTML4 and previous versions of HTML, there's something called strike-throughs. You could wrap an element in a strike tag. But that was removed in favor of the deleted element. So can anybody tell me what the difference is between Can anybody tell me what the difference is between these two elements? If I jump back over here, they both render the exact same. Notice how the browser adds that strike through. But can anybody tell me what the big reason that these two things are different, and the fact that we should prefer the del element over the strike element? No, it's not about shorter. It's about semantics. What does the strike element do? Well, the strike element strikes through the text. That is a presentational thing. That is describing the presentation of something. That is telling the browser that I want this very specific style to be provided to this specific piece of text. The deleted element says something different. The deleted element does not talk about presentation. It just says this element has been deleted. And the browser will have a default styling for that, yes. But it's important because it's a completely different approach philosophically to writing our HTML. This one forces us to think in presentational terms, whereas this one forces us to think in semantic terms. So this one makes more sense to our program. Because what if, okay, so this is a strike, and we use it to strike through stuff. Well, what if we wanted our things that were considered to be deleted to be colored red? Would it make sense to tell the browser to render its strike elements as in red? Doesn't really make sense because strike means strike through, which is a very specific kind of text formatting. Why would applying the strike element make some text red? That doesn't make any sense. So instead we use deleted. Yes, the deleted will default render with a strike through. But if we overrided that behavior so that all deleted elements appeared in red instead of having a strike through, that makes a lot more sense semantically to us as the developers. So I just wanted to point that out. So we have the deleted element. We also have stuff like the bold element and the italic element, which are also either repurposed or removed. If you want to make something bold, what you should do, let's say we wanted to mark our item 3 as important. Well, what's the best way to mark something as important in HTML? The best way to do that is through strong. By using the strong element, we are informing the browser that this text inside of here is important. Now you'll notice that the default behavior of a browser is to turn it bold. But the word strong has nothing to do with bolded text. We can override the strong value or the strong element to be presented however we want. Right, deleted is semantic and strike is styling. Which again, we haven't even talked about styling yet, because styling is what we're going to be focusing the majority of this 4-week class on, but today is all about HTML. Alrighty, so what I'm going to go ahead and do is about every hour into our classes we take a break, and I think that now that I have the entire example written out for you guys, it would make sense to go on a break for a moment. I do see some questions coming in that I will answer once we get off break, and then we will start talking about some more fun stuff. So, yeah. Okay, and we're back. So a couple good questions did come in today, or did come in while we were on break, and they kind of lead into a discussion I wanted to have about inline elements versus block elements. Now, inline elements versus block elements is something that you will need to understand if you want a page to look the way you want it to. We use a variety of different kinds of elements on this page already, and the only way for you to know if an element is inline or block is to know if it's inline or block. So let's look at an example of an inline versus block element. Right here we have this label and an input right here. Notice how when I jump back into my browser, the label and the input are on the same line. That's because they're inline elements. Inline elements get, the elements get combined into a single sort of block that's rendered by the browser. Now that's starting to touch on our lecture about the box model, which will be coming up, but it's important to realize that if I didn't have these dividers in here, now remember, dividers are block level elements. just like H1s are block level elements, or paragraphs are block level elements. If I didn't have these divs in here, these dividers, so I'm going to go ahead and remove them temporarily and show you guys what it looks like. So I went ahead and I took out all the divs. And now if I go back into my browser and refresh, notice how everything is now on the same line. That's because inputs, labels, selects, and inputs, again, submit button is an input, are all inline. That means they get run onto each other on the same line. There's also a couple more inline elements that I wanted to talk about. I've talked about the strong, and a question came in, what's the difference between strong and EM? Let's take a look at it. So I'm going to go ahead and jump to the top of my header. And actually, no, I'm going to open up another paragraph. Then I'm going to write some text. I'm going to say, this is strong, and I'm going to wrap it in a strong element. And this is emphasized. Sweet. Anybody who knows me personally will know what I just did. Okay, so we have two awesome elements that are inline. Strong is inline and EM is inline. What is EM? Well, EM stands for emphasize. And if I go back into my browser window and hit refresh, look at how the text gets rendered. We get this is strong and this is emphasized. The difference between strong and emphasized is more about the strength of your emphasis. And EM is kind of emphasized, whereas strong is really emphasized. They're very similar elements, but their difference is in how strong they are. Now you'll notice that in the browser window, the default styling for EM is to italicize the text, whereas the default styling for a strong element is to boldify the text. Again, we can override that to whatever we want, but that's just the defaults for most browsers. So again, we have a strong element and an EM element. They both do very similar things. It's just the level of emphasis that you want. But it does show a very good example of two inline elements that we can use inside of a block level element. Again, P is block level. We know it's block level because these two P tags are on different lines of the document. So yeah, I just wanted to point that out for everyone real fast because there were a few questions about it. So before we get on to CSS, let's talk about how do we know what elements there are in HTML? Well, fortunately for me, I've been doing web development for 4 or 5 years or so. And so I've kind of had the benefit of watching as HTML5 grew, and every time there's a new element, there'll be a blog post about it or something. But unfortunately, I mean, most of you here are pretty new to this stuff, and you're going to kind of want to get acquainted with what's out there. The best reference that I can show you guys for anything that's related to HTML, JavaScript, or CSS is MDN. Now, MDN is the Mozilla Developer Network. And inside of MDN, you have a lot of documentation about everything you could possibly want to know about web-related technology. So if you want to know what are all the elements that you can use in HTML, just go to the MDN and click on HTML. And if you scroll down a little bit, you'll have an HTML element reference. If you click on that, you get a nice listing of all the awesome elements that you can use inside of HTML. So notice how some of them are grayed out, like strike is grayed out, or font is grayed out, and center is grayed out, and acronym is grayed out. Those are tags that have been removed from HTML. You'll also notice this little 5 icon by some of these elements. That means they have been introduced by HTML5. So that's lots of fun. Now, if you have spent any amount of time Googling about web technology, undoubtedly you will have seen w3schools.com. Now, W3 Schools is not a bad, it's not terrible, I guess you could say. There's a lot of useful information that I find myself running into through Google, and I click on it and it'll tell me what I need to know and I'll move on. But I would be very careful with this particular website. They've gotten a lot better over the years, but just kind of keep an eye on it. If you want to know something definitively, I would highly suggest the MDN over any other reference. There's also some references or some good references on MSDN.com or the Microsoft Development Network, but MDN seems to be, or it seems to have become the sort of definitive web reference on the internet. All right, so that is the MDN. So keep that in the back of your mind if you ever want to know if there's a better element to do something with. So let's go ahead and talk about CSS, because a lot of people have been asking, how do you override how something looks like? And that's kind of what the entire class, these 4 weeks, is all going to be about. But it would be kind of criminal for me in the first week to sit here and talk only about HTML and not even point out where we're going to be moving to for the rest of the weeks. Now, we will be using HTML, obviously, so everything we talked about today is absolutely vital. But we're going to be focusing on another technology, and that technology is called CSS. CSS stands for Cascading Style Sheets, and what it's used for is it's used to have a HTML document and make it look like something else. I can actually show you a pretty good example right now. Let's use the MDN as an example. I have Firefox installed on this guy, so I can go ahead and jump over here and let's take a look at the MDN in Firefox. So look how it looks really nice and has some cool little drop downs and has some interactivity in it and all that fun stuff. Well, guess what? This is all just HTML, and I can prove it to you guys by going to the Firefox menu, or great, they moved it, by hitting Alt, going to View, Page Style, No Style. This is what the MDN looks like. That pretty little page you just saw with all the fancy little typography and headers and footers and all this cool stuff. This is actually what it looks like to the computer. So as you can see, that entire page at the end of the day is really just this document, this HTML document that has been styled by CSS to make it look a particular way. So I'll go ahead and re-enable page styles because this is going to drive me crazy. So that's what it looks like, again, with its styles applied to it. So what we're going to be talking about is, throughout most of this class, is how to turn an HTML document into something that looks like this. I'm not going to be getting into CSS too much here in today's class. We'll be talking a lot about CSS next week, but I wanted to leave people with something a little bit fun to play with. So let's add a style sheet to our document. The easiest way to add a style sheet to our document is to create a style element. Notice how I created the style element in the head element. That is a requirement. You do not want to put your style elements anywhere else other than your head element. Inside of your style element, you can place CSS. CSS is basically just a group of rules, and a rule is a selector and a list of properties. Basically, throughout the rest of this class, we're going to be talking about all the different kinds of selectors we have and all the different kind of properties we have, but let's keep things simple. What I want to do is I want my form to look a little bit more interesting. Right now it's kind of boring. There's no real delineation between these different things other than a line break, and it's kind of, yeah, I don't really like it. What I want to do is I want to make the form a little bit easier to know the difference between these different fields. So let's do that. Wow, I cannot type apparently. All right, so what did I just do? Well, I added a style sheet to my page. I instructed the browser to render out my elements a little bit differently. And with enough rules, enough style sheet rules, you can make this application look as pretty as you want it to look. So let's break down what exactly I did. Well, I created 2 rules. Each rule has a selector, followed by an open curly brace, followed by a closed curly brace. And inside the curly braces, we have properties. So what's the selector do? Well, the selector says, I want anything that matches this syntax to be styled with these properties. So what did I do? I selected by a class name. If you recall, down here on line 30, we have a divider that has the class attribute, and the class attribute is set to form-row. Because I've given this a class name, I can now select it with CSS, and I can make any occurrence of an element with the form row class have a border bottom and a padding. Now, and in this case, I added a background and a padding. We will leave the the lecture about how we specify colors, what padding is, how we specify padding even, to next week. But I just wanted to show an example of this. The final bit of CSS I want to add is somebody asked me, how do we get the browser to have our deletes be different? Again, what if I didn't want my delete elements to look like text that has strike through? What if I wanted my delete elements to have the color red without a strike through? So let's go ahead and do that. What I'm going to do is I'm going to instruct the browser, anytime you see a delete element, I want you to have the color of red, and I want to give you a text decoration of none. By going back to the page and refreshing, we have now changed how our delete elements display to the browser. So again, super fun stuff. We can spend well, maybe not years, but we can spend a long time talking about this, and that's exactly what this class is for, but not today's particular session. Today's session has all been about HTML and how we use HTML to define the structure of our document. To clarify something real fast, it's very common for people to override the styling for strongs and EMs. Remember, EM is the emphasis tag. And what you can do with that is you could certainly make all your strongs look like EMs, or all your EMs look like strongs, or you could make your strongs look like, in reality, you could do whatever you want. With CSS is so incredibly powerful, I could make this strong element animated and dance around the screen if I wanted to, just with using CSS. But that's the kind of stuff that we're going to be playing with a little bit later here. Alrighty, so that is HTML. I encourage everybody to go ahead and type this out for homework, because the act of typing it out is going to be very important to solidify what we have here. But what you guys should immediately pick up from this is that we use the HTML or hypertext markup language to mark up our text that in a way that turns it into hypertext, in that it has a little bit more semantics than just normal paragraphs of text. Lots of fun stuff we can do with it, and that's what this class is all about. But I wanted to go ahead and quickly define one more term. Then we're going to install a web server, talk about what web server is, and that'll be the end of the class. So one more thing, JavaScript. So we are not going to be talking about JavaScript in these 4 weeks. We're not going to be working with it. But what JavaScript would allow us to do is add interactivity to the page. So the pages that we will be building in these this week and the next 3 weeks are all going to be fairly static, in that they're not going to have much behavior. JavaScript is a language that we use to add behavior to our program or to our web application. So I wanted to point that out for people who might not be entirely sure what JavaScript's use is, or might think that HTML is capable of doing things that it actually isn't. HTML does not provide interactivity to your web page. That's the responsibility of a scripting language like JavaScript. Alrighty, so web server time. Right now we are serving, we did get one question that I have to answer. I'm sorry, but it's a good one. Somebody asked, so HTML handles how content is positioned on a web page. And then somebody else asked, where does PHP come into the equation? Actually, you know what? Let's roll both those questions into the discussion about what a web server is. It's time to bust out the whiteboard. All right, let me grab my little handy tablet here and get some whiteboard action going. And then let me lock it down to the right screen because it is going crazy right now. Hold on. There you go. All right. So HTML, CSS, JavaScript, web server, and one more word, HTTP. Now we've all seen HTTP because, well, to have been to 3dbuzz.com, you have had to see it at some point. So let's talk about what a URL is, what a browser actually does, and what a web server actually does. So let's start with the URL. URL could be something like http://3dbuzz. Hold on, I have to get warmed up here a little bit. .com. You type this into your web browser. And so this is your address bar on your web browser. You type it in, you hit enter, and I cannot draw a straight line to save my life. Here we go. There's a box. It's kind of a box. Let me go ahead and clean that little box up a little bit. That's awful, but you guys know what I'm doing. Alrighty. So we have http://3dbuzz.com. This is a URL. URL stands for Uniform Resource Locator. Now we know it's a URL because it has some very important things on it. First of all, it has a protocol, and then it has a domain. Now, if anybody has spent a lot of time working with networked applications or servers or anything like that, you'll kind of know what a domain is. But basically what a domain is a domain allows us to translate a human readable format into an IP address. And an IP address is what allows our computer to know where it's connecting to. So for example, 3dbuzz.com might translate into, I don't know, 5.3.4. How about 0.7? That works too. 0.3.128. I don't know whose IP address that is. Don't sue me if it's yours. So that might be what is that translates into. And what happens is our web browser goes all the way out into the internet to a web server. That box started out okay, but it just sort of blew up at the end, didn't it? There we go. To a web server. Somewhere on the internet. Am I the only one who went to ping that? Again, don't sue me. Okay, so when we're on our browser, we type in a URL. The URL has two things, a protocol and a domain, or an IP address. And the domain gets translated into an IP address if that's what we have. And then our browser sends a request to our web server. Well, how does our browser know how to talk to a web server? Remember, a web server, let me go ahead and dash this line here because in reality, this is over the internet. This could go all the way to China for all we know. 3dbuzz is actually located in Texas. But the point is that our web browser goes out onto the internet, knows where to go on the internet because we gave it a domain, which turned into an IP address, and it talks to the web server, but it needs to know how to talk to the web server. So that's where our protocol comes in. That's where this guy comes in, HTTP. Hypertext Transfer Protocol is what HTTP stands for. Hypertext Transfer Protocol is a protocol for transporting hypertext. And I know I just took that entire acronym, expanded it, rearranged it, and then used it as the sentence to define it, but it's exactly what happens. Hypertext Transfer Protocol, or HTTP, is a protocol. It's a language that our web browsers understand and our web servers understand. So again, this is our browser, and this is our server. When we use HTTP, what we do is we send an HTTP request. An HTTP request is a very specific form of text that allows our web browser to request information from our web server. So what happens when we send an HTTP request to a server? Our browser is now communicating with the server with the format of HTTP. Our web server is going to do something. Well, that's where our server-side languages come into play, like PHP or ASP.NET or whatever. Let's say that this particular web server is built with PHP. So we have PHP code right here. So what is PHP going to do? Well, PHP is going to take our request. This is our request. It's going to go through a pipeline of code, which might include talking to a database. It might include talking to an API like Twitter. It might include reading a file on the server. But the most important thing that it does is it takes this HTTP request that our browser generated and it turns it into an HTTP response. An HTTP response, actually I'm going to draw that over here instead just to be consistent with my diagram. An HTTP response is sent over the wire, over the internet, all the way back to our browser. And then our browser takes that response and displays a web page. So this creates a response. This is the request. So what happens is our browser sends a request to a web server. Let's say we have PHP. That PHP server might do something like reading from a database, writing to an API, reading or writing to a file. It then constructs a response. That response then gets displayed inside of our browser. Almost all of that time, or all of the time that we will be writing code or web pages, the response will contain HTML. This HTML is inside of this response. The purpose of PHP, in a very general sense of the word, is to take a request from a browser, turn it into HTML, and give it back. When the HTML gets packaged into a response, our browser then renders it. And we get a web page. So, again, our browser initiates a request by using a URL. A URL contains a protocol and a domain, typically. It could also contain a port or an IP address. It shoots that request off into a web server. That web server may talk to a database or an API or some file input-output. It may do a bunch of different things. We don't really know what it does. The important thing is that it spits out a response. And that response packet typically contains HTML. If it does contain HTML, our browser will render it. So that's how the data gets from our browser to the web server, then back again to our browser. It's a protocol that's very well established. However, we also have different aspects that make up a page. So we have the data, then we also have the styling and the behavior. So let's go ahead and break out an HTML or a single document. Let's go ahead and break it out and get Photoshop to allow me to translate this properly. There we go. Typically, we have HTML, which contains our data, CSS, which contains our styling. So a CSS document tells the HTML document how it should look. Then we also have JavaScript, which is another file, multiple files, or embedded straight into the HTML that tells the HTML how to behave. And all these different things, the HTML, CSS, and JavaScript, all get served from a web server, and that web server can perform whatever logic that it wants to. HTML can optionally contain CSS inside of it or JavaScript inside of it, or those could be in separate files. We'll talk about them being in separate files next week. So again, there's a big divide right here. Let me go ahead and put in another horribly unstraight line. And that is what the browser sees and what the server sees. The whole point of a server is to just spit out HTML so that our browser can render it. And then our browser gets CSS files and JavaScript files and mashes them all together and gives us a website. So how many people did I just completely lose with this absolutely horrible diagram? Apparently it wasn't that bad. All right, so apparently I lost somebody at example.html. Well, type it out. You'll type it out. It'll make a lot more sense. Okay, so we are going to be using a web server for the rest of our development. And the reason we are going to be using a web server is because we are going to eventually be serving out our CSS files or multiple CSS files, and we also need to be able to have hyperlinks between our documents. When doing that sort of stuff on a file system, it will generally work okay, but it's not the kind of environment that I would recommend anybody do any development or any learning in. So what I'm going to do here is I'm going to wrap up this class with the basic installation of a web server that we'll be able to install on our local computers to work with a web server. Sounds fun and slightly redundant. Alrighty. So the web server that we're going to use is Apache. The easiest way to get Apache running with everything that you could possibly want it to run with is through a package called XAMPP. There are 1,000,001 different ways to install a web server, or specifically Apache or any other web server you might want to install. However, there's a very, very convenient package that we can use. So just go to Google, type in XAMPP, click on the Apache Friends link, and we're going to be using this. Again, there's a bunch of different ways we can do it, but I want this to be the simplest, easiest way for somebody to get started up with a web server. And I want people to work with a web server at the start of them learning HTML and CSS, because you will run into roadblocks and weird edge cases if you don't, if you try to continue to work on your file system. All right, yes, random woman on webpage. It's been here since I've used XAMPP, and I've used XAMPP for 4 or 5 years. All right, so go to XAMPP. Go ahead and click on XAMPP for Windows. And then go to download XAMPP, click that, and then click on the installer. Because I'm a Windows user, I love my installers. And then wait a year for it to download. But while it's downloading, there were a few questions that I wanted to answer. First one is, why do we want to know this? Why do we need to know about what a web server does? If we just want to be a designer, why do we care what a web server is or how it works or what it does? Well, it's because everything that you ever will put into production is going to be hosted on a web server. Furthermore, once you start doing things like having images or style sheets that are in different files, or having links between pages, it is a lot easier to understand and use and to develop for if you have a mirror of a web server on your local computer. The next question is, how much call does a designer have for working with PHP? It depends on what company you work for. Some companies will have designers give developers HTML and CSS mockups, where those developers will then put in the relevant bits of PHP. Some companies will require that designers will be able to work around PHP. It's really dependent on the company. We're not going to be using PHP, but I used PHP as an example in my diagram because it's one of the most common web platforms. Final question I want to answer is, do we need to install a local server if we have a remote one? And that depends on how you work. You can if you want, but I'm trying to show something that everybody here should be able to follow along with. Whichever way works for you is how you should go. All right, so I'm going to click on the installer and get this guy going. So I'm going to hit next. Now I am going to leave everything checked. I mean, I only really need Apache out of all this stuff, but I might as well just install everything. Why not? So then I'm just going to keep on hitting next, close the random web page it decides to fire up during the installer, and I'm going to hit next to install it. But yeah, I highly recommend that people, again, that's what we're going to be working on, and that's why I wanted to wrap this class up with a basic installation of a web server, so that next week, once we start getting into more complicated things like hyperlinks and resources, it'll be easier to follow along with. Because if you're just working on your local file system, things get weird fast. I do not recommend working on your local file system for design or development. And this is taking a lot longer to install than I thought it would, so I'm trying to fill the air with a bunch of empty words. What I mean by local file system is, notice how I just dumped example.html right down here, and then I opened it up in Chrome. Look at the URL. The URL is file://c users Nelson's documents classes HTML example.html. That's kind of nasty. Then that's an example of serving a file from your local file system. When you serve files from your local file system, you run into permissions issues, you run into issues with relative versus absolute pathing and all that fun stuff. It is not worth it, even when you're a beginner. As far as XAMPP is very lightweight. If you're worried about having too much, not having enough room on your computer, I believe the actual thing, what is it? It's only 96 megs. Any particular free website hosting site worth using? I cannot answer that question because I've always had dedicated or virtual servers to work with. Even on my own projects, I always use the dedicated or virtual service or virtual server. Okay, so now it's saying setup has finished installing XAMPP. Do you want to start the control panel now? Everybody needs to pay attention right now. And what I'm about to show you guys is the reason I wanted to do this on video. I didn't want to go ahead and say install a web server, then leave you guys to do, this process by yourselves. And the reason is because there's a very good chance when you hit this start button right now, it will not start up. Now, fortunately, it did start up. Well, unfortunately, actually. But you know what? It very well might not on your computer. For a lot of reasons. And the biggest reason is if you have Skype running when you go to hit start, it'll actually fail. You'll have to start your Apache server before you start Skype. And that's because of the ports that the program uses. A URL, like I said before, a URL is a... Where are you, Photoshop? Get back here. Go away, VMware. Minimize. There we go. A URL contains a protocol, a domain or an IP address, and optionally contains a port number. So for example, I could go to www.3dbuzz.com:80 and hit enter. Now you'll notice that my browser removed the 80 from it, and that's because 80 is the default. 80 is the default port for HTTP, and 443 is the default for HTTPS. I don't want to get into networking here, or what exactly ports are, but I do want to say if a port is being used by another program on your computer, you will be physically unable to start your Apache install. To fix that, the easiest way to fix that is to click on Config, go to httpd.conf, open it up, bring your font size way down because whoever was using your Notepad install last really needed glasses. Okay, so go into your HTTPD conf and look for this line right here. This line tells Apache which port to listen on. If for some reason your Apache install does not start up, follow these steps and change this port to something else, like 45. Save this file and close. Once you've done that, try starting your application again, and you'll notice that it now says ports 85. That means that in order to view my web server, I have to go to localhost 85, and I get my web server. Let me go ahead and switch that back to the default. I prefer to be working on port 80. There's a variety of reasons why you might want to change the port. For example, I don't use Apache primarily in my development. I use another web server called IIS, and I have IIS running on port 80 already. I don't really bother with having Apache also listen on 80, so I changed the port that Apache listens on. But because this is the only web server I've installed here, I'm going to leave that port 80. I'm going to hit stop, then I'm going to hit start. Now when I go to localhost, I get this. It might be a good idea to point out what localhost is. What is localhost? All localhost is an alias for 127.0.0.1. 127.0.0.1 is called your loopback adapter, and that just means it'll point to your current computer. Make sure also, one more quick note for all you Windows users out there, start your XAMPP control panel as an administrator. You want to make sure to do that, otherwise it might not start up properly. But all that complicated stuff aside, I promise that none of this will be that complicated for the rest of the class. I mean, this is a highly technical thing that I very much encourage people to get familiar with because, well, it's just important to be familiar with. So how do we dump a file on our web server? Well, it's actually really easy to do. If we open up our C drive where we installed XAMPP to, there's a folder called XAMPP. Inside of it, there's a folder called htdocs. If I open up htdocs, I get a bunch of stuff. That stuff is actually what I'm looking at right here. Well, I actually could care less about this stuff, so I'm going to delete it. And it's gone. And now when I go back to my local host, I get an empty directory listing. And that's exactly what I want. Inside of htdocs, I'm going to create a folder called week 1. Then I'm going to find that HTML document I created and paste it in there. So again, under XAMPP, which is where I installed it to, then under htdocs, then under a folder I created called week 1, I created a file called example.html, which if I open it with Sublime somehow, I get my HTML document. Now watch this. If I go to 127.0.0.1 or localhost /week1/example.html, I now get my page served through my browser, or served through my server. And we can see that because the URL is now http:// which is hidden by default with Chrome, localhost /week1/example.html. Alrighty. What does XAMPP do exactly? XAMPP is a program that serves out my web pages for me, or my CSS files, or my JavaScript files. It serves it out in a way that is consistent with how things will be served in production. And that's why we're using it. I want people to get used to the idea of working with the web server very early on. And it might be frustrating or difficult to understand at first, and I expect that to happen. But I guarantee you that the only way for something that's frustrating or difficult to understand will get any less frustrating or difficult to understand is to just try to do it. Well, it'll let you know when things go wrong, and more importantly though, it will allow us to next week do fun stuff with linking and resources and stuff like that. How can I view this page from a different computer through the web browser? I'll show you guys how to do that after we stop the video, because I think we're about at the point where we need to go ahead and stop. I know people are going to have to rewatch this last bit one more time, but that's okay. Alrighty, so again, we talked about HTML, what it is, how we write it, elements, tags, attributes. We talked about some basic CSS, which we will be getting a lot into later. Talked about basic forms, talked about lists, headers, sections, footers, and all that fun stuff. So next week, we will be picking up where we left off and dive into some more interesting CSS stuff to get this application to actually look a little bit more visually interesting. So with that, I think it's time to go ahead and head off, so I will see all you future people later.